The printing press led to the Reformation. It led to wars. It led to America and some, etc. Right? So my contention is that AI is going to change our ethical principles, but nobody wants to hear this. Some people go like, that's a curious idea, right? They're sort of like the more intellectual people. And other people just start foaming at the mouth. No. My ethical principles are the right ones forever. Shut the hell up already.
Welcome to SVIC Podcast. Talk about AI, business, and comedy. We are joined today by Pedro Domingos. He has written this fantastic, hilarious book called 2040, a Silicon Valley satire. I was laughing through the whole entire book. The book is so good that I'm spending my own money to buy 3 copies of this book, plus giving away this book to people who are members of our channel, meaning you've hit the join button and you support us for at least $2.99 a month. You go into Discord, and in our free merch and book giveaway, you just give a thumbs up, and you'll be put into a drawing. And even though this book is an advanced review copy, not for sale, it doesn't mean I can't gift it to you. It's also limited edition with my signature, Jordan Thibodeau. I put a heart there. And there's a picture of Joe with glasses, and then me with like a 5 o'clock shadow.
You destroyed the book.
I've added an immense amount of value to
it. When is the official publication date?
August 20th.
Okay.
August 20th. So it's a fantastic book, and so we're really excited to have you here, Pedro. And maybe real quick, you could give everyone who's not familiar with background a quick 30-second about yourself and everything, so we can learn more about you.
Sure. I'm a machine learning researcher. I've been doing since way before it was cool. And then I used to tell people that one day it would take over the world, and then it did. So I feel very vindicated. But now machine learning, every cloud has a silver lining, or the reverse in this case. Now that machine learning is taking over the world, it's causing a lot of problems. Also, the locusts are swarming in, and all sorts of interesting stuff is happening. So I'm a professor at the University of Washington. I've done a bunch of things in research land, also spent some time in industry. People probably know me best as the author of The Master Algorithm, which was an introduction to machine learning for a general audience that came out a few years ago. And to my surprise, turned into a huge bestseller. And, 24 is my next book after that.
Awesome.
Fantastic. We also have a student of yours who's in the channel. He has a pseudonym. He says, Pedro is my AI professor from UW. So he's excited to have you here. So that's fantastic.
We got some moles in the channel.
Exactly.
That's right. And then, back.
Right. And then you're a researcher in ML for Markov Logic Network, enabling uncertain inference. Can you explain to the laity, the plebs, what are the implications of Markov Logic Network?
I mean, honestly, that's my Wikipedia page, and if I was writing it, I would write it in a slightly more accessible way. But hey, I'm glad somebody wrote it. Thank you, whoever did that. Markov logic is a bit of a technical name. What I did, and that is probably my single best-known contribution in AI, is that in AI, as I described in the master algorithm, there are these 5 paradigms in machine learning. But and deep networks, of course, the neural networks is the best known these days. But historically, the most important one has been symbolic AI. And another very important one is probabilistic or Bayesian AI. And my contention in the book and in my research is that each one of these only solves part of the AI problem. And we are only really going to solve the whole problem when we unify them. In the same way that, people in physics unify forces in the standard model and whatnot. So Markov logic is the unification of symbolic AI and of probabilistic AI, which is actually something that, philosophers, going back to George Boole, even before Aristotle, people have been trying to do this thing of combining logic and probability because they're clearly both important, right? You need logic to handle complexity. You need probability to handle uncertainty. The world is both, so you've got to have something that does both. But a lot of people through the centuries have been very pessimistic about this. In fact, when I started out on this, some very well-known researchers said that's impossible. Well, sorry, we did it, and I think it's we did it in a remarkably simple way. The big problem, of course, as always, is scaling up, and then this all got overtaken by deep learning. This was a very hot thing in AI. It was one of the hottest things in AI for like a decade, and then it got completely, swept over by deep learning because of the huge performance advantage of running on GPUs.
Mhm.
But I think this whole story is still being written, and I'm doing research related to this now, and I think we will see where this all winds up. I think there are some surprises coming down the line just based on history.
Fantastic. And I think the way you started, thank you for breaking that down, and that was great. And you had a great tweet that said AI research has exploded in quantity and imploded in variety. So
Exactly.
go for it.
Yes, I agree with that guy very much. So he read my mind.
I know.
I kid you not. I mean, but this is, like I'm still in disbelief at this, because to take the first half of that, the number of AI papers being published today is just mind-boggling. It's thousands every day.
Yeah.
It's probably going to be over 1 million a year. This is unprecedented in the history of science. It's never happened, right? It's mind-boggling. And this is good, right? Because people often don't realize this. Like, since there's now 100 times more research than 20 years ago, other things being equal, we would progress 100 times faster. Yay. The problem is that we ain't, because the research has become so funneled on an increasingly small number of things that it's actually just digging into the local optimum. And again, some of this is just the bandwagon effect that occurs in every area, not just of science, but business, everything. But another one, which I think is also very underappreciated, is that deep learning, right, is neural networks, which for a long time was a ghetto. Nobody was doing it except a few brave guys like, Jeff Hinton and Jan LeCun and Yoshua Bengio. And then that ghetto suddenly exploded. But it's still the ghetto. The people that don't know anything about anything else. I mean, like, I was talking with another researcher, sort of like a younger deep learning guy at iClear a few years ago, commenting on this, standing at his post, and he said, like, yeah, we don't pay attention to anything that's more than 3 years old unless it's more than 30. And this is exactly right. There's all this stuff that happened 30 years ago, and then it came back to life, and now everybody's doing it, not just in machine learning, but it has, consumed the rest of AI, and now it's consuming the rest of computer science, all of science. Pretty soon, the only thing in the universe will just be the Department of Deep Learning. The other thing that's kind of extraordinary is, as it grows, you think maybe it would grow in scope, but no, it keeps shrinking, right? You went from AI to machine learning to neural networks to deep learning, which themselves are a subset of neural networks. Like, not all neural networks are deep, right? Very, very good ones are shallow. To even a subset of that is LLM. So where does this end?
So are you telling me you don't like reading the millionth AI agent paper that tells you, hey, Pedro, we've squeaked out 0.0000000% in performance on the MLU. It just cost us $1 million additional inference cost. You don't like those papers?
I mean, I can't even say I don't like them because I just don't read them to begin with. But at the same time, I have a real problem in that I do want to find out, like, the good research that comes out, right? But I read a lot of these papers, and honestly, my dominant emotion is feeling sorry for the authors. These people are doing stuff that's just incredibly painful, super boring, on this high that they're about to reach AGI with their next tweak. They're going to be very disappointed very soon. But, what can I do? That's how people feel right now, or some people, unfortunately.
I mean, your point's not only that the variety has been reduced and that they're all just focusing in one area, but also that the individual papers are very incremental. They're just taking a very small step and not really researching anything that will have a lasting impact.
I mean, and I would go even further. Incremental research is a problem in every area of science. And some kinds of incremental research are actually fine, right? You have to remember that, like, progress always happens in S curves. And it's something that looks like, incremental before the S is actually not incremental. It's getting you to the explosion. Yep. The problem is the people who are doing things after the S, and that truly is incremental research that isn't going to make any difference. And there's too much of that. Now, but the problem that we have in deep learning today is not only that the research is incremental, is that you pick up a random paper out of arXiv today, and there is essentially no research in that paper. The papers are more and more details about how we ran this and that and the other, and like the actual new idea in that paper is almost none, sometimes truly none, right? Yeah. And the thing about this that makes me sad is that AI is not a sprint. AI is a marathon. Particularly, in industry, there are a lot of pressures. You do have to deliver results on fairly short order, whatever, my friends at Google would prefer, for example, would prefer to believe. These days, it's not even that much of mystery. But like in academia, our whole, the point of our existence is to be working on the long-term problems, ignoring the short-term constraints. But people aren't doing that. They're all just falling into the same ultra-narrow short-term bandwagon. I mean, I share the excitement, but let's have a little bit of foresight and, knowledge of the past and projecting it into the future. And if you look at the more serious, smart, knowledgeable researchers, they know that AGI is not one LLM tweak away. So
sweep the leg. No
Their
mercy.
hopes are dashed.
We use that audio when someone says something so clear and awesome. They get a Karate Kid, sweep the leg, no mercy. So, yeah, I mean, you must be looking at this all saying, oh my God, all the crypto bros left and then moved to AI. And now I'm just hearing all of this crazy stuff about ASI tomorrow, AGI tomorrow. And you're just sitting here saying, like, where do these people come from? And then why is everyone focused on them right now?
Well, to be fair to the crypto bros, right? I'm not a fan of crypto, but that's a different subject.
Mm-hmm.
This whole delusion that AI is just around the corner is 70 years old.
Mm-hmm.
People have been following it from day one. In fact, the founders of the field, Newell, Simon, McCarthy, Minsky, they were famously under the illusion that AI was just around the corner. Within a few years, we'll have computers that beat people at everything.
Mm-hmm.
So they were crazy, but they were good crazy because they started the field. And honestly, when I was 20 and got interested in AI, I had a very brief period that was like, wow, let's go, right? And then I realized, no, this was the AI winter. We're in this for the long haul. And my position was like, you should be working on something that is bigger than yourself. It's like a cathedral. If it's not finished in your lifetime, that's fine. But in every generation, there's people who feel that way. And now, there's this generation who are like the students of, Jeff Hinton and Jan LeCun and whatnot. Like those are the people who, and now there's a sort of like a new generation even that they're the people who populate the open AIs and deep minds and whatnot. And they really are on this gate that we're going to solve AI. There's this AI seems to be a way easy. This is like the number one reality about AI is that it seems to be so much easier than it is because we humans do it all subconsciously. Vision, manipulation, language understanding, it seems so easy.
Mm-hmm.
But evolution spent 500 million years optimizing us for that. So it's really, really hard. And too many people, including researchers, don't quite get this. And that's where you get all of this over-optimism. And then, of course, there's the opportunities. There's a whole flood of opportunities coming into AI now. And people who've been, major AI experts for 3 weeks and think, they nailed it.
It's funny because you're sort of, I guess, dampening their prospects or raining on their parade. But at the same time, if I go back to your thesis in the master algorithm, it's that I think you're saying if there's a way to achieve this, it would be by synthesizing these different approaches.
Indeed. And in fact, I'm an AI optimist. I do believe we're going to solve AI. It's very, like people, journalists, etc., like to play this game of like, so when do you think AGI will happen? And the truth is nobody knows, right? But so the answer that I give to that is a century, give or take an order of magnitude.
Mm-hmm.
It could be 10 years. As I say in the master algorithm, for all I know, there is a kid in the garage right now who has invented the learning algorithm that does what the brain does with less complication. You unleash it and we're on a rocket to the moon.
Yep.
Even then, it would take decades to play itself out. But that is, I think, very unlikely, but not impossible. At the other end, there are people who credibly say that AI is just too hard, right? There's this famous saying that if we were so simple that we could understand ourselves, we'd be so stupid that we couldn't. Now, there's good reasons why I don't believe that, but you got to take that position seriously. So, there's this whole spectrum now. As Alan Kay said, one of my favorite quotes is the best way to predict the future is to invent it.
Mm-hmm.
It depends on us.
Yep.
Whether we're stalling with the end of an S-curve or whether there's another one coming up, this is not predetermined. It depends on people coming up with the ideas. I remember talking, this is actually, like in retrospect, so hilarious and unbelievable. I remember talking with Ilya Sutskever and I cleared in 2017. 2017. So, OpenAI was fairly new then. And Ilya was saying, deep learning is plateauing. There's less progress. I was like, no, I don't think so. Yeah, I can understand why you'd feel that, but deep learning is big enough and varied enough now that the chances are something else will come up. And I made an analogy with support vector machines that also had various generations. It was like, no, I'm not the only one who believes this. A bunch of other people like me. Like a month later, the Transformers paper comes out. So, I rest my case.
Right. And his reaction to that paper was drop everything with these recurrent models and just jump on this transformer.
I mean, to his credit and to the credit of OpenAI, this is actually the single biggest thing that they did right, was that they did jump on it with full force. It wasn't just it wasn't just the paper, it was their own work that they were doing with LLM-like things, which again, this is a recurring motif in all this. And again, I have a lot of fun with it in 2040. The whole, sorry to the, all my friends and smart folks at OpenAI, but the whole history of OpenAI is a comedy of errors.
Yeah.
It's like they screw something up that actually turns out to then be great. And like they started out doing this stuff with a language model for sentiment analysis, basically doing stuff that was already, decades old, that they thought was new, that they did worse than everybody else. But that got them into this arena. When the Transformers came out, it worked well for them. And then they pivoted. But the whole way this whole thing happened was just way too random for comfort.
You mentioned 2040 and sort of using the ideas and sort of what's happening in the environment as kind of your raw material. Will people recognize themselves in the book?
Oh, I hope so, and I know so. Right? It's so the book actually, I think, works, or hopefully works, on two levels. It's a book that a layperson who's curious about tech world and AI and how the sociology and politics around this developing should be able to read and have fun. Like think of Silicon Valley, the show, right? It was for the general public. But at the same time, everything in the book is a spoof of something real. Mm-hmm. It's like some of them are more insider than others, but like people who know AI, who are in the industry, they will read those things and fall off their chair laughing because like they know what I'm making fun of.
Yep.
Oh, no, I had that because I used to watch HBO's Silicon Valley because we were both at Google, and so Joe wouldn't watch Silicon Valley because it was like the Legend of Dorian Gray in the mirror. Because if he saw it, he would die.
It was too painful.
Because it was too painful. Because I would sit through episodes like, oh my god, these are slides from one of the meetings I was in. This is terrible. And then I was reading your book, and you have this section where they end up going to the HQ of this company in San Francisco where the AI is developed. Right. And it was just so cringe-inducing because I'm like, this was my life for a good 10 years. But then you have this other segment where, so they're talking about PreziBot, and PreziBot's like this AI AI mixture of robots running for president. Mm-hmm. And here's a line that says, I just called Oakland Robotics, said Arvind. They said they'll have it fixed in a week. A week, said Rossi. We have less than a month left in the campaign. Can they speed that up? They need to order some parts from China, said Arvind. Ross shook his head in disbelief. Imagine if the media got a hold of that, he said. So there's just little bangers like this consistently in this book that got me laughing. And so it's definitely worth the read. So well done. Like, what inspired you? Were you just you went from master algorithm to then, hey, I'm going to go into satire, which is a completely different part of the brain.
A big style jump.
It. Yeah.
No, a lot of people ask me this question, right? But actually, paradoxically, it makes a lot more sense than you might think. So for a long time, I'd been trying to persuade some of my friends, like, for example, journalists, who deep down what they want to do is write the great American novel. No. You should write the great Silicon Valley novel. You can't beat writing the great American novel is too damn hard at this point. But the great Silicon Valley novel, it's like wide open, and you know it. So write it. But people kept not writing it. So in the end, I said, well, I'll do it myself. Exactly the same thing that happened with the Master Algorithm. I was like, you should write a popular science book about machine learning. There's a crying need for it. And nobody then was like, okay, I'll do it then. Right? In the previous life, I actually had learned how to write science fiction. I went to this famous thing called the Clarion West Writers Workshop. So I felt that I at least had a shot. Now, what I really didn't have, and again, complete analogy with the Master Algorithm, I didn't have an idea on what the story would be. And you can't really write it until you have the story. And that idea came to me, in an interview, a journalist asked me, so would you vote for an AI for president? And I was actually taken aback for a moment, right? I'm not easily taken aback, but I was. And then I said, well, no. But if the other candidate was Trump, then yeah. Right? And the thing is that, like, an AI candidate, if you think about it right now, imagine, like, this book is basically ChatGPT runs for president, right? Like, I mean, the jokes write themselves, but imagine for a moment ChatGPT running for president. Like, it's a terrible idea. But it's all relative. If the other candidates are bad enough, then ChatGPT starts to seem pretty attractive. And I submit that we're there now. Trump and Harris, in their own different ways, are so bad that maybe ChatGPT would be better. We can go into more detail on this, but, like, I would vote for ChatGPT over either of those people.
Yes. Yeah, but now you're mixing. Well, I guess you have a wider field because you have both politics and Silicon Valley to make fun of.
No, yeah. So there's another. So why did that idea appeal to me? And now there's sort of like the intellectual level and the visceral level. The visceral level is that, honestly, once that idea was planted in my mind, the story just grew like a kudzu vine, right? It just kept, picking up more strands. But the other thing is that, and for example, in contrast with Silicon Valley, which again I loved, like that, the startup there, what is their product? It's a compression algorithm. I care about compression, but nobody outside of tech does. They, who cares, right? It's a completely mundane thing. And part of the dirty little secret of Silicon Valley, which we all know, is that as much as it's the gold rush and all of that, most of the stuff that happens there is super mundane. It's like, my startup does better check processing. We are going to revolutionize the world, It's just like, come on, man. You're just recognizing digits on checks. Like, don't get carried away. But now, to write an interesting novel, right, you want to up the stakes. And that's when I realized this is really the linchpin of the novel, is that, like, what could be bigger stakes than the AI robot is running for president? And now suddenly all these jokes like, it's malfunctioning and you need parts from China. This is not just the life of a startup. It's the future of the country. And of course, the other way in which I up the stakes is that the other candidate, is a fake Native American chief that wants to abolish the United States. So there's these bumbling fools in this startup, which you can laugh at. But if they screw up, it's the end of America.
Yeah, the Brave has an AK-47 in the election. Like, it was ridiculous. And then
this is just turning up the stakes.
Intersecting circles. You had AI, plus you had the presidential election. But then you can interweave, like, polling data. And here's a section of the book that I loved. Okay, so they're talking about, so they had this thing called PreziBot. PreziBot had a snafu where someone gave him too vigorous of a handshake and he fell apart. So now they're trying to decide, do we reassemble him? What do we do? Or we just do a virtual, just a little image of him. And it says, what's amazing is that anyone is willing to vote for a candidate that can't even stand up, said Kowalski. No, people can tell the difference between the robot body and the actual AI, said Arvind. The brain is what counts. I don't think so, said Kowalski. In fact, the whole point of having a body is that voters subconsciously see PreziBot as more of a normal candidate. Normal candidates are overrated, said Arvind. But they win elections, said Kowalski. Machines don't. We should have stuck with a virtual avatar, said Emma. None of this robotics crap to deal with. You saw the poll, said Ethan. People are much more likely to vote for a candidate with a body. And I was like, God damn it. Because I was like, this actually makes sense. And I used to work in politics. I know how important polling is. And I'm like, this is just like, it's almost coming out of a pollster's mouth. It was perfect.
No, yeah, so, and I mean, like, so the people that they're talking to there, right, are their campaign strategists.
Yeah.
And this is how a campaign is run, right? And the thing is that, like, part of the joke here is that PreziBot is hard to manage, but then again, so are real candidates.
Right.
In their different ways. There's this scene in which the Republican and the Democratic campaign manager are comparing notes, and each one of them is commiserating with the other because, in a way, they both have a difficult, job, right? Raging Bull is like a left-wing Trump, he keeps shooting his mouth off. On the other hand, PreziBot is an LLM and is prone to hallucinations. and the thing that, like, one of them is very bitter about is that, like, the robot bot is giving them all these problems, and they didn't need a robot bot. It could just have been a chatbot. Technically speaking. On the other hand, the polls say you need a body, so hell yeah, we got to have a body. Just like
it's very Silicon Valley to avoid the hardware.
Popular, right? That's how it works, baby.
Yeah, that's so true.
But I think, Pedro, it's very Silicon Valley to avoid the hardware and just focus on the software, right?
No, in fact, in that scene, right, like, so PreziBot has fallen to pieces, which, by the way, is an illustration of Moravec's paradox, right? PreziBot actually, they have a debate. PreziBot actually does very well at the verbal sparring, which indeed LLMs are good at, but then the physical body is what screws up. So PreziBot, again, this is illustrating a very important real point.
Yeah.
So they're trying to, Ethan, who's the protagonist, is the CEO, and he's more of the salesman and the megalomaniac. he says to Arvind, who's the CTO, well, come on, now let's fix this thing, right? And
Mhm.
Arvind says like, I'm a machine learning guy. I don't do hardware. Leave me alone.
Right. But now you have to
I
give
know
people.
people like that. I'm like that. I wouldn't want to
Yeah,
be
yeah,
fixing the hardware of the robot. Hell no.
That's a classic specialization excuse in Silicon Valley, right?
Yeah.
Not even hardware, software, just front end, back end, etc. But so first of all, we should back up a little bit and explain Hans Moravec and his paradox. But also, you're sort of touching on embodiment now.
No, yeah, so exactly. Both of those things are very important issues in AI, which again the novel tries to illustrate. So Moravec's paradox is this fact that, Hans Moravec, a roboticist at CMU, was kind of like the first one to spell out, because we've been seeing it for a while, which is that the things that seem to be easy for AI are hard and vice versa. The things that are easy for humans are hard for AI and vice versa. So for example, this is actually very unintuitive. It still trips people up, and it has major consequences for society, for the economy. For example, white-collar jobs are much easier to automate than blue-collar ones. We can automate a doctor right now. We've had for decades medical diagnosis systems that do diagnosis better than a doctor. Lawyers, etc., easy to automate. Construction workers, no.
Yep.
We will automate doctors and lawyers long before we automate construction workers. So this is Moravec's paradox. Embodiment is this whole debate, which LLMs are the latest instance of, where do you, at the end of the day, does your AI need to be in a body to really learn enough to have human level intelligence? And at the end of the day, and this debate is playing out right now, of course, the people who think you can just learn from text are having a heck of a ride. But people like Jan LeCun, of course, is a vision guy at heart.
Yes,
I'm
Jan
like,
is very much on the embodiment.
Not getting anywhere. For most of my life, I have mostly worked on the text mining side of things. And the conclusion that I have come to is that no, for interesting reasons, at the end of the day, we can have an infinite amount of text, trillions, quadrillions, quintillions of words. That is not going to be enough. But in the meantime, if you want to make short-term progress, that is a really sweet way to go, because you have these bazillions of data points that you don't have anywhere else.
Process.
So I'm actually all for taking, AI is not going to evolve in the same way that humans did, because the constraints and the opportunities are different. So I'm all for going with that all the way, right? So I don't disagree with what OpenAI is doing at all. We just shouldn't be in the delusion that that's going to take us, all the way to human level intelligence.
But carry it forward the next step. I mean, you could add to that images and video and stereo video and audio samples, and you're sort of inching towards being embodied. But I think a lot of people would argue that's still not the same as actually being embodied and getting real sense data and interacting with the real environment.
No, very good. So in fact, the stock answer to this point that I just made is that but now what we have are, multimodal models. They have vision, they have all of these things. And I'm like, absolutely, more power to that. That is definitely the way to go. But now there's two very important caveats here. One is that, first of all, actually more than two, but the first one is just using transformers on those data isn't going to cut it. It'd be nice, but it ain't. And again, transformers are a great advance. I'm not trying to poo-poo them, but nobody knows how to do video understanding right now. Truly, nobody knows. People are focusing on the stuff that we can do, like generate pretty whatever, nothing wrong with that. But video understanding is a different thing. We need fundamentally new machine learning vision algorithms to understand video, number one. Number two, it's not enough to just mine large quantities of data like LMs do. You need interaction with the world. The key element of embodiment is interaction. There are these beautiful experiments in psychology where you put two kittens in a mechanism. The one that controls the mechanism learns to see normally. The other one is functionally blind.
Yep.
There's nothing wrong with its visual system, but it's blind because it doesn't know what anything in the visual world means. And it's going to be the same thing with AI. I had a conversation with a colleague of mine at UW who's also a director of research at Facebook, at Meta. And we were talking about this, and he was like, oh, yeah, we're doing a lot of multimodal stuff, et cetera, et cetera. And I'm like, oh, cool, right? This is the way things should go. But then he was like, but the reason is that we're running out of data. So, and this is the reality. A lot of the people who are doing the multimodal stuff is just because we don't have any more text data. People don't talk enough, right? We can't, we need to, why don't we talk more, darn it? People start talking.
I think also your point is you can pour more data and different types of data onto the system and get improvements, and you should do that, but it's still not actual interaction with the environment. It's not a natural experiment.
Indeed, and in fact, in machine learning, there's this whole subfield called active learning, where instead of just passively mining the data, you actually choose which data points you get. And active learning is orders of magnitude more. What might take a billion examples, 99 point, like you see this, for example, in self-driving cars. They have millions of miles of driving, most of which is completely redundant. And then they keep getting these corner cases where you wouldn't screw up, but the AI does. So interaction, I mean, look at a kid, right? A kid playing. The smartest thing that a human being ever does is when they're two and they're playing. They're doing experiments to learn the next thing. It's not even just random interaction as the world brings it to you. And the thing is that, like, at the end of the day, with that process, you have acquired the basis that nobody knows how to verbalize. This is the crucial thing, is like, we don't know I know how to ride the bike. I don't know how to explain to someone how to ride the bike, let alone program a computer to ride the bike. That can only be learned by doing. Luckily, computers can do that. The problem is that robots don't gather data at the speed that the internet does. So we do have a problem right now.
Yeah, your point is you're not going to learn it by reading about riding a bike.
No.
And you're not even going to learn about it by watching videos of people riding bikes. You're going to have to actually try your own theory of what it's like to ride a bike.
Exactly, which in our brains is subconscious, but actually a very sophisticated theory. In fact, this, again, a lot of people find this counterintuitive or disagree. Your brain knows more physics than Einstein. Einstein knows physics of very remote phenomena, like, near speed of light and very large masses, all good. Your brain never learned that because it didn't need to. The world it evolved just didn't involve that. But in terms of everyday physics, Newton's laws are sort of like, they don't really capture. It's almost an illusion to think that those laws tell you everything. We know about chaos. We know about dynamics and whatnot. Like, your brain is amazing at dealing with the real world, with running in a jungle and jumping over things, like, in a way that we have nothing in all of engineering that compares to that right now. And this is actually the most important thing, is that, like, children, you and I, we can learn from a tiny number of examples because we're able to generalize very far from them.
Yep.
You see an elephant once and you know an elephant is forever. And of course, there's many strands of machine learning, trying to do this, but we haven't cracked it. We still need way more, AlphaGo beat Lee Sedol because it played 1 million times more games than he ever had. If you had to, this to me in some ways is a fairer contest, is like, compare a machine and a human that learned from the same number of games. Who wins? The human being just blows the machine away. It's not even...
Yeah. That's an interesting challenge. So bringing this back to your previous book, is embodiment and the learning that occurs through embodiment, is that part of is it necessary to the development of AGI? Is it part of sort of a master algorithm?
So I would say, the thesis of the master algorithm is that there is this thing called the master algorithm, which is one algorithm that can learn everything.
Yep.
And I bring together a lot of different evidence towards this point. Some theoretical, some empirical. But the simplest empirical one is that, look, we have two real examples of that. Your brain, right? By definition, a master algorithm can learn anything that your brain does. Your brain, if you believe it's an algorithm, is such a master algorithm. Evolution itself is a master algorithm because it produced your brain. So the goal, right, of machine learning, explicitly or implicitly, has always been to come up with these algorithms that are very, very general. The same algorithm can do completely different things, like play chess or fly a plane. Now, that algorithm then needs to be put in the body in interaction with the environment to then truly learn to do the things that humans do, like, run away from the tigers or do the dishes or whatever else it might be.
Right, but flipping it over, I could also say, I think, there has to be a body and you have to be able to do natural experiments in order for that intelligence to develop.
No, absolutely. And in fact, this is really a part of the barrier, is that the thing that has gotten us to where we are, and again, I think a lot of people, even in technology, don't truly appreciate this, is the methodology of machine learning, which is what I learned in grad school more than anything else. It's this methodology that we take for granted, of, like, you take a data set that is real. It's not some toy world. We know that fails. DeepMind didn't know that fails, which is, again, another interesting part of the comedy of errors. But we take real data sets and then we randomly split them into train and test. And then you can do whatever the heck you want, but it doesn't matter until you do well on the test data. This is the scientific method at the speed of computers. It's a really crucial idea. But the problem is that we are now running out of road with what we can do with that. Trying to do the same thing with real interaction is way more difficult, way more expensive, right? Way less convenient. You're a grad student. You need the paper in 6 months and the PhD in 4 years.
That's right.
You know, great. I can download these data sets. That's what I did as a grad student and play with them. The whole interaction thing is like, 10 years. And robotics, right, is so much harder than software, right? As, again, 2040 illustrates. So there's a reason people aren't doing it.
Interesting. I'm curious what you think of the simulation environments like the ones that NVIDIA is trying to provide, and then the transfer of sim to real.
Good question. Simulation environments have a long history in AI. And what has always happened is that, because this is such an obvious thing, it's like we should try things. And in fact, this is the way the whole DeepMind approach to life was, let's do things in simulation. Mm-hmm. The problem with simulation is that it always winds up being, you wind up over. So actually, let me do the positive case first, right? When I learned to drive, I took the first few lessons in a simulator. And then I started to drive a real car. Mm-hmm. And for those first few lessons, that's actually good. Mm-hmm. And OpenAI actually did some clever things with robot hands, you guys might remember, where basically they did so much work in simulation that it could transfer to the real world fairly well. So simulation can get you some of the way. Mm-hmm. But then the problem is that machine learning in particular has an uncanny ability to zero in on whatever in the simulation is not the real world, but lets you do well. Because the simulation is an oversimplification of reality, right? And the oversimplification, of course, is what the learning algorithm is going to key in on. So in a way, AI spent 30 years trying to do things in simulation or in simplified worlds like Block's world and law, which were mostly simulated, and failing. Yeah. Failing. It took off when in machine learning, we said, no, from now on, we're going to do things in, it's like, you have to be a mosquito in the real world or a bug, and then you'll have a chance to become a cat or whatever. You're not going anywhere until you can do something on a real task. And I think this is still true. Where is DeepMind now? Their whole agenda was like, we start out in these, artificial environments, and then we're robots. With all the admiration that I have for the folks at DeepMind, that is going nowhere. Their big thing now is proteins, which is great, but again, it's a somewhat simplified world. So this wisdom that simulation won't get us there continues to hold.
Well said. I was showing the game called Coast Runner 7, where DeepMind was learning how to play it, and then eventually the algorithm learned, if I just go off course and go in a circle constantly, I can get the most points ever, which is like, you're winning the game, but you're cheating at the same time.
No, I'll give you an example. Remember Atari was what first made DeepMind famous. I had a student working on that. We actually, to my knowledge, we have the first ever reinforcement system that learns to play the games better than humans in fewer games than humans. DeepMind think way more, but it's so brittle that, for example, their big success were this thing where it makes a hole in the wall and then starts hitting breakout, right? And they're like, if you change the location of the ceiling by 1 pixel, it goes back to being as bad as random. Yep. This is how bad it is. Changing the ceiling by 1 pixel makes it crash to random performance.
Right, you need that robustity, which is really important.
Very brittle, very overfit.
We had a comment from Maj in our comment section. To what extent, this is for Pedro, to what extent does scale play a role in such master algorithm? Does the bitter lesson still apply?
Great question. It's one that's a very big one and controversial one in AI, but I think people tend to get it wrong in a number of ways. So let me give you the 2 poles and then what I believe, right? By the way, I actually spent most my early career scaling up, right? Scaling up algorithms. So there are the people of which, OpenAI is, I'll pick on Ilya, right? Ilya Sutskever is the ultimate example of like, we're going to go all the way just by scaling up. And as we've been talking about, this I think is an illusion. And I would say most of the better researchers agree it's an illusion. And we can go a little bit more into why it's an illusion. At the other end of the spectrum, however, I have people who think like scaling up is just, that's engineering. You can push a button. There's no real scientific question there. Scaling up is not important. We got to go and figure out AI. This is also a mistake. Intelligence is all about scaling up, right? When you scale up, the complexity goes up, the number of data points goes up. That's when you have a brain. right? Without intelligence, without scaling up, if you have a computational problem that's not large scale, you don't need intelligence for it. You can just build a finite state machine. So like you have these things like I have come up with this objective function. I could pick on specific people, but there's only, and this new objective function is the solution to the AI problem. That is also a complete delusion. The real action is going to happen when you try to optimize it on a very large scale. Now, what happened to me early on was that, I got my PhD in the 90s, and our preoccupation right then was to take the machine learning algorithms of the time and scale them up, because they used to be super linear. And our hope was that if we can make them linear, then with the data that we now have, maybe we'll go all the way. And then we actually wound up succeeding so well that at one point I had theorems, and I won a bunch of best paper awards and whatnot for this, showing that what these algorithms would learn if they were given infinite data. I could bound the difference between what the algorithm was doing with finite data and what we would if it had infinite data. The algorithm, this is not the ordinary learning theory that's about some representation, the actual algorithm. And even with infinite data, these algorithms, like for example, learning decision trees is a classic example, or k-means, they are still very stupid. No amount of scaling up, all of our effort, as good as it was, to enable a lot of things, would get us there. At which point I switched gears to working on precisely Markov logic. So at any given point, I think there should be people who are working on scaling up the open eyes of this world. There should also be people who are working on the next generation of algorithms. Because here's the thing. A human brain is not a scaled up ant brain. You need to figure out how that brain, and then you need to scale it up. So actually you need to alternate or do the two things at the same time. And right now we're sort of like in full scaling, mode. But my research is actually, I'm working on a deliberately small scale, on the simplest, interesting data sets that I can to really figure out the next generation of algorithms. But then, of course, we're going to have to scale that up, all the way. That's also an essential part. And it'll be a scientifically interesting problem, the scaling part as well.
Yeah, I think I could describe your overall philosophy as, when you're in a regime where scaling is working, press it to the limit. And then when it stops working, or maybe ahead of time, start thinking about what the next paradigm, the next S-curve is going to be.
Absolutely. I would modify that in the following ways: that different people can be doing different things at the same time. You don't need to wait. You should definitely, like, for example, in our current moment right now, we should have people who are just scaling up all the way. But we should also have people working on the next thing. The problem that we have right now is that everyone has converted so much to the scaling up part that nobody, there's a dearth of people and ideas on the other side, which in the long run will be the more important one to get us to the next S-curve.
You've kind of hinted a few times at what you're working on now. Can you give us more background on what you're trying to do and what you think it'll achieve? So
what I've been trying to do, and going back to the master algorithm before, is to unify all 5 of these paradigms. And what I have, and I've been doing this and others. I'm not the only one, of course. We did it 2x2 and then 3x3. And in the master algorithm, I had a sketch of how the whole thing would work, and the problem was scaling. What I have now is actually something, that is just completely irrelevant. I have a much better way to do this now.
You're really recommending your previous book.
Well, in a way, I'm recommending it. Well, yes and no, right? So
historically,
as a survey of machine learning, the book is surprisingly current. There is nothing there that's out of date. There's things that have happened since that I didn't cover. But I wrote the book with that in mind. I want to focus on the things that have been the same. The paradox of machine learning is that it's 70 years old. There's constant novelty. The key ideas are all 50, 67 years old. These paradigms have been the same ever since then. So if you focus on those things, you will not be outdated, and the book still isn't. Having said that, the specific way in which we were combining, these different paradigms, we naturally now have a much better one. In particular, the main thing that I'm working on now is something called tensor logic, which unifies deep learning and symbolic logic in the same way that Markov logic unified probabilistic and logical.
Interesting. And if someone wants to follow your current work or your recent work, is this published? Are there places to learn about it?
This is not published yet, but hopefully it will be soon.
I've made this teasing us. You're just teasing us.
Well, you asked the question, so I had to answer it, right? I wasn't,
Oh my God.
But I mean, so caveat, right? Everything, it's the old saw. In theory, there's no difference between theory and practice, but in practice there is. So the experiments that I have taken advantage of the fact of being, as people say in the Valley, post-economic at this point, to actually be completely outside the pressures of you need to publish and whatnot. And I've just been trying to make the fastest progress in the right direction that I can. The thing is that, like, to publish a paper, writing a paper is quick, but you have to do a whole set of experiments and blah, blah. And what I have noticed over and over again, now we're seeing this today on the biggest scale ever, is that everything that you do to then publish that result, you start converging to a local optimum.
Yep.
It's inevitable. And then once you're in the local optimum, it's not just the time that you spent getting there, it's the time that you spent digging out, right?
Yep.
Like, think about this way, like when you're at a local optimum, as for example we are now, your biggest barrier to progress is the state of the art. The state of the art is the hole that you have to dig yourself out of. So I'm trying to sort of like make the fastest progress possible. The experiments that I've done so far are simple. The method works, but there's no guarantee that it'll work when I scale it up to the size of, a trillion words or whatnot. It's at the end of the day, machine learning is an empirical science. So I'm very excited about this line of work, but like when it comes out or we talk about it again in years or whatever, it could be that I'm like, whoa, this is amazing, right? This, all transformers, that's all obsolete now. Or actually now, we just ran into some big wall that we didn't see.
Some practical limitation.
Yeah, it could, I don't know, it could go either way. The only way to do it. This is what makes it fun.
It's interesting as a researcher. I mean, a modern researcher could publish, or they could write on a blog, or they could do interviews. There's lots of ways for them to get their research out into the public. Do you feel like as a researcher you have more freedom now than you would in the past, or is it worse somehow?
In some ways we have more freedom, and in other ways we have less. So you're right that we can publish in all these ways, but then what you think, but here's the real question is, if you want to do a piece of research and have it be successful and have its rightful impact, what do you need to do? The problem is at this point, it's actually harder because you need to do all of the above. So if you look at the labs that have mastered this art, DeepMind, OpenAI, et cetera, what they do is it's like a pyramid. Like there's a tweet or maybe a tweet storm backed by a blog, backed by a paper, backed by a GitHub repository with a ton of data sets and code and whatnot, right? And in a way, that whole pyramid has to be there. Most people will only see the tweet. Some of them will look at the blog, and then some will look at the paper. I personally, when I see the tweet, I go to the blog and say, like, where's the link to the paper? And I go to the paper. But for most of the people, that's not so. So you have to do all of the above, right?
Yep.
And any one of these is a point of failure. The thing is that, like, and in some ways, I feel sorry for the people who are like grad students now. I used to read the entire proceedings of ICML and NIPS. Not read every page of every paper, but read every.
ICML.
Yeah, ICML. Those were for a long time the two main machine learning conferences, right? The ICML, which was the Symbolic AI one, and NIPS, which was the deep learning one. Again, like that whole dichotomy has always been there. But these days, that's just impossible, right? And then what do you do? Like, let's say you're a grad student, you just done a brilliant piece of research. Just making it rise above the noise is almost impossible, right? You spent a year of your life on that, and people are going to read the title of your paper and go like, boring, next one. They're not even going to process it, right? They're not even going to read your abstract. It's like, and the other part of this that's very perverse, and again, this keeps happening over and over again, is that, like, we're at the point, and like really we as a community need to jump out of this, is we're at the point where if your thing doesn't beat the LLMs that Google and OpenAI and whatnot have built with bazillions of dollars in resources, then you're not in play. Yeah. This is suicidal, right? Like somebody could invent the true next big idea tomorrow, and people are like, oh, you've only done these experiments, and like never mind, reject. And then how do you make yourself heard, right? It's very hard.
Well, in fact, that's what we did to neural networks when the hardware wasn't there. We essentially said, oh, we tried this idea. It doesn't really work that great. It's impractical. And we went with other techniques for quite a while.
I agree with you, but I'm laughing because in machine learning world, there are these cycles. There are these oscillations. And one of them, which we actually alluded to earlier, very interesting one, is like, are we data bound or are we compute bound? In certain decades of machine learning, we were data bound. So then we needed smarter algorithms. Right? When we're compute bound, we need to scale up. right?
Yep.
So this is one cycle. Another cycle, which is actually not uncorrelated with this one, is between being more empirical and being more theoretical.
Mm-hmm.
What happened in the 90s and 2000s so the previous coming of neural networks was in the 80s and 90s. And neural networks, to their both advantages and disadvantages, people never pretended that you could do any good theory about them. I mean, some few people did, but by and large, the practitioners were like, it's Jeff Hinton's mantra was, it just works. And someone said like, but your probabilities are coming out negative. And it's like, I don't care, I'm Jeff Hinton, I can get away with negative probabilities, which he can, and it just works, right? So that was the mantra. And then there were these 20 years of Bayesian learning followed by kernel learning, which were super theoretical, mathematical. It was all about, do you have the theorems? And again, there's a joke that in machine learning, there's two kinds of people. The ones that read the paper front to back. If they like the theorems, then they skip through the experiments. And the people who read them back to front. If they like the experimental results, then they go back and bother to find out what the paper is trying to talk about, right? And so this pendulum keeps swinging, right? And now it has swung just brutally in the strongest fashion ever to the completely empirical side of things.
Yep.
Right? And for all I know, there'll be another swing of the pendulum next decade. Again, the most important pattern in the master algorithm, which could again be true today or maybe not, is like every decade of these 5 paradigms, a new one is on top. In the 80s, it was neural networks. And that's when NIPS was created, it was called Neural Information Processing Systems. By the 90s, the presence of the word neural in the title of a paper was the strongest indicator of rejection. Because if you were still submitting papers on neural networks to NIPS, you were completely clueless. In fact, the joke was that at that point, it should have become BIPs, Bayesian Information Processing Systems, and then KIPS, Kernel Information Processing Systems. And I remember joking around with Yoshua Bengio in 2009. This was the ICML in Montreal where he's based. They're like, so what's the next decade going to be, right? And I said to him, right, I was just starting to dabble in deep learning, and he was, he'd been doing it forever. Like, the next decade, meaning 2010s, is going to be DIPS, Deep Information Processing Systems. And Yoshua started laughing because he couldn't picture that ever happening. Like 2 years later, deep learning was on the front page of the New York Times. And of course, that was nothing compared to what we're seeing today. So what's the next decade going to be? It could be more deep learning, or it could be something completely different. It could
by your reasoning, it should be symbolic information processing or something like that. We should rotate.
Exactly, should rotate, for example, or it could be evolutionary, right? One of the paradigms it could be, or it could be analogical, right? This is actually coming from psychology and whatnot. This is actually is if you come at AI from psychology, analogical reasoning is how we do everything. Douglas Hofstadter has this famous, there's the famous book of Lescherbach, but he has a more recent one, which is about how all of cognition is just analogy. It's 400 pages saying it's nothing. So for all I know, analogical learning will be the 2030s.
Our benchmarks will all be Bongard problems, right?
Well, yeah, again, there are people today like, from Strasholé who are saying like, we need to go back to these kinds of simple problems because they're the ones who really, we human beings clearly have something that can do that with, half a dozen examples, and LLM just completely crashed. So there you go.
We need to leave some time for you to tell us about what you're working on now and what we should expect next.
Sure. Yeah. Which of those do you want to... So actually, I'll just put it this way. What I'm working on now is what we can expect next. So, it's one topic.
It's one and the same.
No, I'm saying this jokingly, but the thing is, if I say to people that I'm working on is the next big thing, right? If I thought something else was the next big thing, I'd be working on that. So it's really a redundant statement to make, right?
And are you going to write another book? And if so, which genre will it be in?
Yes, I have, more books that I want to write than years left in my life. So I have to prioritize ruthlessly. But I do want to write. So, writing this book, fiction, was kind of a lark. It was a one-off. It was fun. It also hopefully serves a useful purpose. But honestly, at heart, I am not a fiction writer. Right? I know people who are, and they just have, a certain kind of mind. I'm more of a scientist. I'm more analytical than synthetic. Let's put it that way. So the next books that I want to write are nonfiction. I want to write, and in what order I write them in depends on a couple of things. But one book that I want to write is because I think there's such a crying need for it, is a book making sense of AI, not just as a technical area, but like what AI means for the world, for you, for society, for the economy,
consequences,
for politics. And honestly, one of the reasons there's a crying need for that book is that the discourse around this right now is so impoverished. It's ridiculous. I mean, I'll give you one small example.
Yeah.
There's this whole area of, AI ethics, right?
Mm-hmm.
AI ethics consists of people trying to shoehorn AI into their current ethical systems.
Mm-hmm.
And I mean, if AI really is the biggest thing since fire, for sure it's going to radically change society, right?
Mm-hmm.
Think of the printing press. The printing press led to the Reformation. It led to wars. It led to America and some, etc. Right?
Mm-hmm.
So my contention is that AI is going to change our ethical principles, but nobody wants to hear this. Some people go like, "Huh, that's a curious idea," right? They're sort of like the more intellectual people, and other people just start foaming at the mouth. No. My ethical principles are the right ones forever. Shut the hell up already. So that's one example.
That's a much more radical kind of change to our ethics, or to the field of ethics.
Well, I mean, like a lot of the things that we take for granted. I mean, like every age, right, has principles that it believes in, and that it believes are immutable. But the truth is, they're specific to that age. So, for example, our values right now, like 500 years ago, there was feudalism, and they had a whole ethical system that made sense with feudalism. And then the people who traded took over. We are their children. So we have an ethical system now that is the one that works for the traders, the bourgeoisie, etc. Right? I mean, like, this is just being realistic. AI is going to change the economic order. The people who are going to have power are going to change. The ethical systems of the future are going to be the ones that serve the people who have power in the future. There is no social dynamics by which this doesn't happen.
What's the working title?
The working title is AI and You.
Awesome.
Because I want it to be about AI. And again, like another thing that I'm trying to combat is that like people's eyes glaze over when they start talking about AI. Well, you're going to cure cancer tomorrow. It's like for you, in your life, in what you do, in what you believe in your job, in your dating, in like, how is AI going to change your life? And how can you be prepared for that? So it's actually a book with a very utilitarian goal, right? We've had these books coming out, some of them by people I respect, but honestly, the books are like, hand waving, like, AI, this, that, and the other. It's either going to be a utopia or it's going to kill us all. And it's like none of this is that useful. These are all distractions.
Interesting.
Pedro, how much more time do you have? Do you have you have a few more minutes? Joe, what about yourself?
I'm good.
First of all, I was going to say we have a mug here that you've earned because you've been on the show. It's called our AI Doomer Tears mug. And so it says launch, but we'll all be turned into paper clips. So you're getting a free mug. And I just want to talk to you about go deeper into this vein of thinking, because we don't think about how technology evolves us as a society and changes what we think is possible. So maybe go deeper into that. And then I'd love to hear your thoughts about all of these nations are running around saying we're going to create like compute laws, and you can only train models with so many flops. Like, what are your thoughts on all about this thing? I'm just trying to get this AI to go through 2 pages without self-destructing. That's all I want. And these people are talking about, well, they're going to get the launch codes eventually, and they're going to kill us all. So, like, what's going on here?
So I'm already laughing. By the way, I love what you just said there. Like, I'm going to steal it and tweet it as soon as I get off. This is like, technology evolves us. That is brilliant.
Thank you.
And we all know that we evolve technology. What none of us seem to is like technology does evolve us, right? Like those are 3 words that contain multitudes. So yeah.
Thank you. I got one good idea. Joe has out of every 10,000 ideas, Joe's are 9,099 correct. Me, it's 1 is good and the rest are trash. If you just link the podcast too, it'd be fantastic. But please continue.
No. I had it. I'm erasing this podcast and I own it. I will have you bumped off by the...
and I'm gone.
Sorry, you're just in the way of my rise to world domination now. Like, first things first.
Hey, so long as everyone votes PreziBot and also buys the book, which is fantastic.
We don't have to worry about the AI taking over.
By the way, right, as you've probably read, like the attack line that the other side picks against PreziBot is to paint him as a menace to humanity. right?
Yeah.
So at one point, Ethan asks some random guy, so who you're going to vote for? And he says, well, between the end of America and the end of the world, the end of the world is worse. So I'm going to vote for the guy who wants to describe that.
I don't know if I want to laugh or cry because it's so relevant to us.
So,
Probably accurate for the average American.
but to answer your question, right? Illustrating the points that we've been making about more of X paradox and people really not grokking where AI is going, we are having, and I'm laughing, but this is actually tragic. We're having all these laws passed that are extremely noxious. Europe has one. California is about to pass one. Biden has an executive order. As you already alluded to, like, these people never learn or they never knew, right? Like, it's like saying like we're going to regulate models that have more than X number of parameters is like in 1980 saying we're going to regulate computers in more than 640K of RAM.
No one needs more than that.
Are you kidding me? But on the other hand, sorry to get into politics for a second here, the head of the AI task force is Kamala Harris, who we all know is a world expert on AI, right? And then it's down.
Pedro, you're going to get us banned.
We're already blocked.
Yeah, we're canceled.
I mean, there's funny things on both sides here. And again, by the way, like, one of the key points of satire is that it attacks everybody equally. Right?
Yes.
If satire is only banging on one side, it's not good satire. Most of the book is banging on the Republican candidate,
yes.
right? But you got to bang on both sides on this.
I was comparing your book to Bonfire of the Vanities, but I should have gone for one of the Jonathan Swift books. That's who you're really in line of.
No, actually interesting, because the inspiration for the book, I should probably have mentioned this earlier, was the Bonfire of the Vanities.
Yeah.
Because the Bonfire of the Vanities went and took the iconic industry of the 80s and the whole world around it and basically blew it apart. And I've always thought, like, someone needs, that was actually my idea. My pitch to, like, my journalist friends was like, why don't you write the Bonfire of the Vanities of the tech industry? Now, of course, the style of the book is very different. Bonfire is full of, like, very deep description, and nobody has the attention span for that, let alone the tech industry. This is a book that you want to read in a couple hours. So yes, but you're right. In terms of, satirizing everything equally, equally ferociously, I think, yes, Jonathan Swift is more like the model for that.
And he went after the scientists of the day.
And like, and I'm a scientist as a result, and my parents were scientists. So I know all the foibles of the scientists as well as anyone, right? And again, I'm illustrating them in the book, right? The two protagonists are grad students of Professor John Jeffington, who published a paper in the Conscience on novel information processing systems, which, the acronym is NIPS, which is actually, again, it's a joke because new information processing systems turned out to be the wrong name for that. But in any case, we digress, which is easy when you're talking about 2040. There are all these laws being passed that are going to be serious. I mean, like, AI, I believe, truly is going to be trillions of dollars of GDP, right? We're going to, over the next 100 years, we're going to double or more GDP based on AI. You can't put in place laws that make that impossible based on these mistaken fears and based on your lack of understanding. I'll give you an example. So the European AI Act, it outright outlaws a number of very important applications of AI. They had it ready to go a couple years ago. Some of us warned them, this is going to get outdated very quickly. When ChatGPT came out, they had to scramble to revise the laws to apply to the new models. But now, in another 2 years, it's going to be outdated again. Don't they learn the lesson?
Right.
So we're making AI laws for yesterday. But AI is the technology of the future. And moreover, like, I sympathize with the legislatures to some degree. It's like, AI is not a technology like cars or planes or drugs that they're used to regulating. The essence of AI is machine learning, is that the technology is continuously evolving. So you can't have a fixed set of rules about AI like you can about a car. It just doesn't work. But try to get a politician to grok this is very hard work.
Well, plus the pressure on them to, quote, do something.
Right. You got to take action. You got to take an action, because if I'm in office and I'm not taking action, Pedro will say, well, I'll take action. Even if the action's bad, people say, well, at least Pedro's doing something. There's my vote.
Yes, there's pressure. They feel the pressure to do something. And like, this is something that congressional staffers have told me while talking about AI, right? Because I don't know if you know this, but across the United States, since ChatGPT came out, almost 1,000 pieces of AI legislation have been introduced. Almost 1,000. So everybody wants in on the action, right? And partly it's because they feel like they do something. But what these guys told me, which like I should have realized in retrospect, was like a lot of the people doing this, they're promoting their own career.
Mm-hmm.
They want to have their name on an AI bill. I am Senator blah, 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 and I wrote the AI bill, like vote for me because I'm so great.
That's
and whether the AI bill makes any sense, that's something for the staffers to figure out. This is how things actually work.
These are the locusts that you opened up describing.
In some ways, yeah. The other one, by the way, which hadn't occurred to me, but in retrospect makes sense. So first of all, on the optimistic side, talking to some of these staffers, one of the things that they told me was like, don't worry. Yeah, you're too worried. Most of these bills, and now we're talking about the U.S. Senate. I don't know about all the state ones. Most of these bills are dead in the water.
Right.
The media is still talking about them, but like, forget them. They're not going anywhere.
Yeah,
but none of the remaining ones, they're the ones that are motivated by getting ahead. But the other big motivation they said, which is interesting, is that like there are senators who just hate the guts of the tech companies, and they will use any tool at their disposal to cudgel them with, and AI is just the latest tool. So they're going to use and again, this is how the real world works. Like they're making legislation about AI, not because it's good for the world, but because it allows them to attack their enemies.
Well, I got a strong sense of that with the privacy legislation coming out of the EU, that at least some of the people drafting it were motivated by their hatred for American tech companies and what they had done to European media companies.
Oh, absolutely. So Europe has a particular problem that the US luckily doesn't have, which is that, I've talked with people in Europe. I'm European originally at all levels, including, the European Parliament, ministers, etc. And they have a problem in that the US at least has tech companies that will lobby and make themselves heard and have a lot of jobs. And Europe doesn't have any of that. So if you look at tech from the point of view of European industry, it's all a threat. It's all bad. And
right.
and who has the ears of the legislatures? It's these media companies. It's just like
right.
It's sort of like this process by which it's almost impossible that any even-handed AI legislation will come out of it at the end of the day. And then they say things to me like, "Oh, but we talked with a whole bunch of AI experts while drafting this legislation. What's wrong with you?" And I'm like, "Tell me what legislation you want to pass, and I'll tell you which AI experts to talk to."
Right.
And guess who the companies pointed them to? The expert who said, like, no, these guys are wrong. It's, the American, tech giants that are right.
Right.
That ain't going to happen.
That reminds me of the other point of, my dogs are our senior fetch reporter. She has a question. Hey, Pedro, huge fan here. Quick hypothetical for you. Let's say through a comedy of errors, you've landed a life sentence in jail. Now you've got to pick a cellmate to chat with till the end of your days.
Oh, God.
Your options: Eude, Gary Marcus, or Connor Leahy. Who's your pick and why?
Wait, who's the first one?
Ebenezer.
Eliezer
Yurkowski.
Wow.
Gary Marcus or Connor Leahy.
Dear friend, you truly are a sadist. This is just pure sadism, like unadulterated. Can I pick your dog instead?
She said that was the correct answer because the other correct answer was can I get lethal injection? But that was a good.
No, talking with your dog, come on, it's better than lethal injection.
Yes.
I like your point about the politics in Europe, and it sort of struck me as you were describing it that it's kind of in our interest, like from a global perspective, to get some successful tech companies in Europe, just so there's some input to their political process.
Oh, for multiple reasons. Like one of them is that more variety is better.
Yeah.
I often tell people in Europe and other places, they don't necessarily like to hear that, like, the problem in the world is that there aren't enough Americas. Having an America is really good. And, Europeans and Americans are totally free to have different priorities and whatnot. That kind of variety is good. But we are too dependent on this one country. Right? And, things in America can go bad. Many people would say they are going in bad, from whatever angle they're coming. So if we had half a dozen Americas, the world would be a much more, it's like model ensembles in machine learning. You don't want to have only one model, right? I wish there was a European Google. I wish there was a European Amazon.
You're right. Nassim Taleb, if he was watching, would say, "Yeah, you want for AI city states like Greece, just all these little AI models checking each other, and not just having these gigantic organizations that can easily be corrupted or can decide, hey, we're not going to release this anymore, so everyone else suffers.
No,
So
absolutely.
yeah,
Now, and now, so there should be a European AI ecosystem. Now, for Europe's own good, for Europe's own prosperity, GDP, they need AI. And then third, and maybe even the most important point, is that we are in this contest between democracy and autocracy. And I very strongly believe democracy is better. But China's a lot bigger. This notion that facing up to China is America's job is mistaken. We need those 500 million Europeans doing their maximum, along with the 300 something million Americans, or we're hosts. So wake the hell up, Europe, already.
preach, amen.
Yeah, I think your position is not only that there's not enough Americans, but that there's not enough Americas.
No, enough Americas. In fact, it's this interesting trade-off, right? Because on one hand, network effects are very important. We know that, right? But having, what we would, for example, breaking America into two would be bad, because you do want the critical mass, right? Hundreds of millions is actually good. A unified market with, that's great. It works for America, right? If only we had it in Europe. If only, why doesn't Latin America get its act together? This is what Bolivar wanted. They wanted.
I was just going to say that
united, right? Like,
I think Pedro, what's going on with Brazil right now? Even though for Portugal, but what's going on in South Latin America? There's a lot of great engineering talent coming out of there, but it's like, where's their AI champions? Where's their major tech companies? I'm not seeing it.
I mean, indeed, and one step behind that, right? They need a level of development that would happen more easily if they were more unified. And I think the next World War III, right? Saying this, not entirely seriously at this point, I hope, right? Well, if the most likely countries World War III is to be between is America and China, right? But as 2040 briefly illustrates, China won that one, right? So the next one, I would guess, would be between China and Africa.
Oh,
yeah.
I would have thought
China will be a unified continent. It will be huge, both in numbers of people, right, and in having a more distributed model, less because you have to remember that these country boundaries were put there by the Europeans. They're not the real ones.
Right.
So if you look at it from the point of view of this combination of size and diversity, Africa, once they get over their problems, could be a superpower to contend with China.
That's so true. Yeah. We're going to have one of my friends on. He runs a startup. He grew up to about 300 employees. He started in India, but now he's hiring more and more people in Africa because he's getting really top engineers out there. It's just dealing with the internal country dynamics and things like that. So, Pedro, this has been fantastic. There's an old saying of just let them cook when someone's on a roll. Always want to keep talking. And this has been fantastic. So thank you so much for coming through. Everyone, check out his book, 2040, A Silicon Valley Satire. You will continuously laugh through his book, and you'll also think. And we have 4 free copies of this book that I'm giving away. So just support our channel. Go to Discord, and we have a book giveaway channel that you can put your name in the raffle and get a copy. Pedro, thank you so much for coming through. When you come out with more research or you decide to come out with another book, I would love to have you back because you're just a wonderful person having a show. And so thank you so much for your time. I really appreciate it.
Absolutely. Thanks for having me, and thanks for letting me cook.
Oh, anytime, buddy. Stay on here for a second because I'm going to turn off the live stream. And then everyone in the live stream, thanks for watching. I'll see you all in the Discord for the discussion about how this podcast went and everything, because I know you all have a lot of great comments. So Pedro, hang on for a second. Everyone else in the chat, I'll see you in Discord. Peace. Hey, thank you for watching the show, and a special thank you to our Patreon and YouTube channel members who keep the show going. If you love our deep dives into AI, business, and comedy, why not become a supporter on Patreon? For $2.99 a month, you'll get exclusive access to our 100-member Discord community, free book giveaways, and awesome merch discounts. For $5 a month, enjoy our ad-free hour-long episodes every week, plus Q&A sessions and access to all the previous bonus content. And for $10 a month, your questions and reaction requests for Joe and I will take priority. And you can get a free mug if you purchase an annual membership at this tier and save 10%. So if you can support the show, go to patreon.com/SVIC or hit that join button on YouTube. Talk to you later. Peace.